All right, hello Algebra 1 honors. Today we're going to start looking at section 1.4, which is solving absolute value equations. And it gets interesting real fast, okay? Yesterday on the board I talked about, we discussed what absolute value means, and some of you brought up that it's the distance a number is from zero, and that is the technical definition of it. Other people said that it's kind of a number's true value if you ignore positive and negative, and that also I think rings true. And then somebody else said, hey, it means that the number is always going to be positive, and that is true as well. So what today we're going to look at though is solving absolute value equations. And there's a few things we need to be wary of. Let's go ahead and we'll start with an example. Let's solve. And we've got absolute value bracket x plus 6. Close the absolute value bracket equals 11. Well, what this means in reality is that what's inside this bracket could be 11, because what's the absolute value of 11? 11. Or what's inside the absolute value bracket could be equal to a negative 11, because what is the absolute value of a negative 11? Well, it's 11 as well. So what I would suggest you do is whenever you have an absolute value bracket by itself equal to a number, write two equations. X plus 6 equals 11, x plus 6 equals negative 11, and then that will in turn enable you to solve it and get your two possible solutions. Use the subtraction property of equality, you'll get 5. Use the subtraction property of equality, you'll get negative 17. And I would encourage you to check these answers and see if they in fact work. And you'll notice that they do. So it's pretty common with absolute value equations to have two solutions. One for the positive value, one for the negative value. That will work. Let's try another one. Absolute value bracket 2x minus 1 is equal to a negative 4. Now, like I said, this is going to get interesting real quick, because if you take a look at this, if you rush into things and you're like, all right, absolute value bracket's by itself, so I'm going to write two equations. If you do that, you're going to find out something doesn't quite work. And here's the issue. Absolute value bracket, if you take the absolute value of a number, it's always what kind of number? A positive number. So what we have here is when we've got this absolute value bracket equal to a negative 4, there's nothing we can put in for x that we can then take the absolute value of this expression and get a negative number. So whenever you come across an absolute value bracket equal to a negative, you can cut to the chase and say, no solution. No solution. And I should say that if you did write your two equations and solve them out, if you then checked, you'd find out, oh, these don't work out at all. They don't work. So let's try another one. Let's move right along. Negative 5 times the absolute value bracket 3x minus 6. After the absolute value bracket plus 9 equals negative 3. Now we got more going on here. It's not just an absolute value bracket then an equal sign. Well, what we got to keep in mind is that on this first problem, we wrote two equations when the absolute value bracket was equal to one thing. Okay? Over here, what we've got an absolute value bracket, but there's operations on the outside of it. Okay? So before we write our two equations, we actually need to find out what exactly can be two possible answers. So what you're going to want to do is you're going to want to isolate the absolute value bracket. You want to get it by itself. And we've learned how to do this using properties of equality. Ideally, you'd probably go ahead and subtract the 9 over. We've learned that you could divide by -5 to undo that, but you would then have to distribute the division to here, and of course do the property of equality and do it over there. I think it's going to be a little bit more straightforward to go ahead and undo that +9. Now you might be a little bit wary and think, oh, wait a second. But we don't have the absolute value bracket by itself yet. So we need to do that. Let's go ahead and divide by -5. Division property of equality, -5. That divides out. We're left with absolute value bracket 3x minus 6 equals, and it's going to be a fraction. You could write it as a mixed number, but mixed numbers are kind of difficult to deal with, to perform operations with. So I would prefer just to realize, okay, negative divided by negative is positive. We're just going to leave it as 12/5. Now, something I should have mentioned before we started was there's some people that have an inkling to take this -5 and distribute it. Now that'd be okay to do if you had parentheses or just a regular grouping symbol, but an absolute value is a special grouping symbol, okay? You cannot take a -5 that is not the absolute value and distribute it into an absolute value. So notice whenever you're encountering this and you've got multiplication with a bracket, you always are going to do inverse operations to undo it. All right, at this point, it appears that we can get 2 solutions. It's positive. So let's solve our 2 possibilities. It could be that 3x minus 6 could be positive 12/5, or it could be that 3x minus 6 could be negative 12/5, and it would work out. And 2-step equation, let's add 6 over. When we add 6, we're going to have to be careful here because we're adding it to a fraction. So when we add 6, I'm going to move off to the side here and write down 12/5 plus 6. I would like for us to get a common denominator here. So what you're going to want to do is you're going to want to rewrite 6 as something over 5 that is equivalent to 6. So what I would do is actually multiply it by 5/5. So you would get 30/5, which I hope you agree is 6. Now we've got a common denominator. We can go ahead and add those together and get 42/5. 42/5. And then finally, we're ready to divide by 3, but because we have a fraction over there, I'm not going to divide. I'm going to undo this 3 by multiplying by the reciprocal. And we're almost there. At this point, you can multiply straight across and then simplify, or you'll often find it easier with smaller numbers to go ahead and simplify before you multiply straight across. And so 3 goes into 42, I think 14 times. I believe that's right. Yeah, that's right. So what we have then is 14 times 1, which is 14, and then 5 times 1, which is 5. We got 14/5. So that's one of our solutions. Same sort of setup over here. we're going to add a 6 over, add a 6. But again, we're going to have to get a common denominator, so we're going to have negative 12 fifths plus 30 over 5. And we add the numerators there, we'll get 18 over 5. And again, instead of dividing by 3, let's instead multiply by the reciprocal, which will undo the 3. And so we multiply by 1/3, multiply by 1/3. Again, I'll go ahead and simplify before multiplying straight across, because 3 goes into 18 6 times. And we get an answer of 6 fifths. Now, some of you might be a little bit antsy about this. Maybe you had a teacher that said you should always change an improper fraction to a mixed number. Not so, not so. You'll find that a majority of math teachers, they appreciate this format better because it's so much more usable. You can immediately use it to perform other operations.